Hello everyone. Today let's solve the problem R2D2 and Droid army. Right. So this was asked done code forces around 291 for the division 2. Right. So I can just go through the question. It is easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. So what the question states here, just give me a second, 1 second. Yeah. So what the question states here, we have n droids, right? So just remember this one. We have n droids, each with m types of details, each with m types of details, right? So we have n droids, each with m types of details. The ith droid has counts a1 to am, right? So the ith droid has counts a1 to am, right? So this is fine. We have n droids, each with m types of details. The ith droid has counts a1 to am. So we may make at most k shots, man. Out of this, we may make k shots, right? So we may make at most k shots. Each of type I decreases every droid's AI by 1. Each shot of type I, what it does, decreases every droid by 1, right? So we may make at most k shots. Each shot of type I decreases every droid's AI by 1 or A by 1. That is floored at 0 basically, right? So this we'll see later. So we have to choose the shots per type. So the longest contiguous subsequence of droids becomes fully destroyed. Longest contiguous this one subsequence of droid gets fully destroyed. So we have to choose the shots per type. So the longest contiguous subsequence of droids becomes fully destroyed, right? So a droid is destroyed when all its detail counts reach 0. A droid is destroyed when all its detail counts reach 0. Just keep this in mind, right? So again, I'm gonna read out this one very loud. Just listen to this, and then we can just move on with the input output part, right? So we have n droids. See here, we have n droids, each with m types of details, each with m types of details. The ith droid has the counts a1 to am. See here, the ith droid has the count a1 to am, right? So we may make at most k shots. We may make at most k shots. Each shot of type I decreases every droid's a or ai by 1, right? So this part we have to choose the shots per type. So the longest contiguous subsequence of droids becomes fully destroyed, right? So what we need to do, we have to choose the shots per type. So the longest contiguous subsequence of droids become fully destroyed. A droid is destroyed when all its detail count reach 0. All its detail count reach 0. This one part, right? So this is fine. So we are done with the question part, right? So let's move on with the input output part, man. Let's move on with the input output part. Let's see. So now, just give me a second here. Yeah. Mm, 1 second, man. Let me remove this one entirely. Yeah. Let's come to the input output part here. So, mm, I hope you have listened to the question part correctly. So let's come to the input output part. We have been given 5 to 4. This is nothing but n, and this is nothing but m, and we have discussed this one k as well, right? So this is nothing but k, right? So droids, these things whatever we have given, droids 40, 12, 21, 102 and 10, these are the droids basically, right? The first line they have mentioned 5 to 4, nothing but n, m and k, right? Accordingly with the question, these are 4012, 2102 and 13. These are the droids basically, right? So this is one based index. Always remember one thing here, these are droids and this is one based index, right? So this is what, one based index. Just remember this one, don't forget this one. So this one thing can ruin the entire problem. This is one based index, right? So here we need to get the output 2 comma 2. Same goes with the second input as well, man. Right? So I'll consider first input for the approach. So you can just do the same thing for the, or you can just implement the same thing considering example 2 or the input 2. within the question, right? So again, the first line is n, m, and k accordingly with the question, and this one 4 0 1 2 2 1 0 2 and 1 3, these are droids, and this is one based index, right? This is fine. We are done with the question and the input output part. Now, as we are completely familiar with the question, let's do one thing. Let's get into the approach part. So first, let's discuss the approach followed by the complexities, and then let's write the code. First, let's get into the approach part. So here, let's do one thing. I'll just go with the first example or the first input that they have given in the question, right? So we have n here, m and k, and these are the droids we know. The output that we need to get here is 2 2. So we can just go with the this one, droids we have been given in the form of queries, right? So we can just go with the segment tree or the sparse table, right? So I'll just go with the sparse table, as the code will be little small compared comparatively with the segment tree, right? So there is no updation required here, so we cannot go with the Fenwick tree or the BIT. Either we have to go with the sparse table or the segment tree. Let's go with the sparse table, right? So the output that we need to get here is 2 2. This is fine. So let's go with the step-by-step explanation. So n we have 5, m equals 2, k equals 4. Same thing, droids one based index, and this one we have the droids here, one that is mapped, right? So as I have said, one based indexing. So this is mapped to index 1, this is mapped to index 2, this one 2 comma 1 is mapped to index 3, 0 comma 1 is mapped to 4, and 1 comma 3 is mapped to 5, right? So this is fine. Now let's let me go with a quick reminder of the rule used, right? So for a window L to R, for a window L to R, the shorts needed for the type I is max of column I over the rows L to R. Just remember this one, man. So if you don't remember, just leave it as it is. Now for now, let's move on with the further things. So just remember this one, total shorts equal sum of these per type maxima, right? So total shorts equal sum, just remember this one, total shorts equal sum of these per type maxima, right? So we want the longest window with the total shots less than or equal to k. This is accordingly with the question that we have discussed. We want the longest window with the total shots less than or equal to k. So the code keeps a sparse table per column for max of left comma right, right? So this is window left comma right, this one queries, and uses a sliding window L comma R. That's what I meant basically. Uses a sliding window L comma R to find the best window, to find the best window. This we will see when we write the code basically. If you don't understand the theoretical part a bit here, don't worry, I'll be explaining that one while I write the code, but keep certain things in the mind. This one you have to know at any cost. Total shots equal sum of this per type maxima, because we'll be discussing the iterations, and that calculation part you have to know, right? So here, what we'll do, sparse table per column for max L comma R queries, and uses a sliding window L comma R to find the best window. This is fine. So we use zero based indices in the tracing. In the tracing part, we'll be going with a zero based indices. We'll start with L equals 0, R equals 0, max len and best. So these are the four things that we'll be using for the calculation. Left, right, max len and best, right? So initialization part you have seen. So next, let's move on with the iteration one. So total we have 8 this thing, right? So we have to go with the 8 this one, uh 5 droids we have, right? And n we have been given here nmk, yeah, nmk we have been given 5 2 and 4, right? So 5 droids, 2 m is 2 and k is 4. So this is fine. First let's move on with this one iteration part, then let's see. So element droid 1 is we have 4 comma 0, the first droid we are considering here, this one 4 comma 0, right? So the first droid here, we are considering the first droid here. Per type maximize, type 1 equals 4, this one, type 2 equals 0, right? Sum equals 4 plus 0. When we sum this one, we get 4 plus 0 equals 4, which is less than or equal to k. K we have been given 4 itself, right? 5 to 4 we have, yeah, 5 to 4 we have. Just give me a second. We have 5 to 4, and 4 is less than or equal to 4. Yes, it is. So this window is valid, man. This window is valid. And length equals 1, max length equals 0. We will update the max length to, so as we are going with a sliding window, we will update the maximum length to 1. Best is currently, the best is 4 comma 0, right? Action is this one, right? will increment the right as well, because we have to move from left to right itself, right? Right becomes 1, max length becomes 1, and the right becomes 1. Currently best is 4 comma 0. This is fine. Let's move on with the second iteration now. So we have the window 0 comma 1. Initially the window was this one. For the first step, the window is 0 comma 0, right? So this one I didn't mention here. So this one is window 0 comma 0, right? So now we are going with the iteration to window 0 comma 1. So we have droid 1 to 2, right? So we have 4 comma 0 and 1 comma 2, two droids. So 1 comma 2, the second droid, right? So we are going with the second droid, this one 4 comma 0 and 1 comma 2. So type 1 we have max of 4 comma 1, max of 4 comma 1, this one, these two, max of 4 comma 1, and this one type 2 max of 0 comma 2. Max of 4 comma 1 is 4, and type 2 max of 0 comma 2 is 2, right? So we have got 4 2, right? So we will sum these two things. So we will when we sum we get 6, right? 6 is less than or equal to k. 6 is less than or equal to k. No, k we have 4, right? So 6 is greater than k, right? So 6 is greater than k here. K equals window, this window is invalid. Basically we will shrink from left. So now we'll not be going with a r plus plus, we'll be shrinking left, means we will be incrementing the left pointer. Basically this will be l plus plus, so l becomes 1 from 0, right? So this is invalid window, right? So let's move on with the iteration 3. We have to go with the window 1 comma 1, right? Window 1 comma 1. So droid 2, droid 2 we have 1 comma 2, still we have 1 comma 2, right? So that was invalid. Previous step, that was invalid. So we will be considering droid 2 here. Basically this is still 1 comma 2, 1 comma 2, right? So I'll just come here, just give me a second. 1 comma 2 maxima type 1. So this one type 1 is 1 and type 2 is 2. Type 1 is just 1, type 2 is 2. We will sum these two things, we will get 3, and 3 is less than or equal to k, or 3 is less than or equal to 4. K is 4, right? So yeah, 3 is less than 4 basically, and this is valid. Window becomes valid, right? So length is 1, max length is still 1. Will not be updating this one. Action again, our right pointer, we will be incrementing the right pointer. This becomes 2, this becomes 2. We are seeing the pure this thing, what do we call, sliding window here, right? So let's move on with the fourth iteration. So we have to consider window 1 comma 2, droid 2 to 3. We'll be considering 2 to 3, and for the third droid we have 2 comma 1, right? So see here, first droid 4 comma 0, this one is first droid, this one is second droid, this one is third droid, this is fourth, and this is fifth. For the third droid we have 2 comma 1. We are going with a 2 to 3, means 1 comma 2 to 2 comma 1, right? So just give me a second here. Yeah, this one here 2 to 3, 1 comma 2 and 2 comma 1. So we have to consider max of 1 comma 2 and max of 2 comma 1, right? So max of 1 comma 2 is also 2, max of 2 comma 1 is also 2. So we'll be going with 2 plus 2. 2 plus 2, when we sum up, we get 4. 4 is less than or equal to k, nothing but 4 is less than or equal to 4. Yeah, 4 is equivalent to 4, right? So this condition is holds good as well, means the window is valid, right? So the window is valid. So length equals 2, we have maximum length, we will be updating the maximum length from 1 to 2. Now the maximum length becomes 2, best is 2 comma 2, right? So best we are updating the best to 2 comma 2, right? So again we'll be updating the, I mean we have to move the right pointer ahead. So r plus plus r becomes 3 from 2, right? So pure sliding window. This you have to know. We have solved a number of problems using the sliding window already. So let's go with the fifth iteration. Now we have to consider window 1 comma 3, droid 2 to 4, means 2 and 4 we will be considering. So droid 2 we have 4 comma this one 4 0, and droid 4 we have 0 comma 2. So these two things we have to consider, right? 4 comma 0, 0 comma 2. Yeah. So droid 2 to 4, window 1 comma 3 we are considering. So we need to consider 2 to 4, means third one also we have to consider. So previously we had considered uh, second and third one. So third one also comes here, right? So this is third one, this is fourth one. Yeah, 2 3 4, sorry, don't get confused here. This one, third one also, dot 3 also we are considering. 2 also we are considering. 2 is nothing but 1 to 2. 3 also we are considering along with the 4. So this one has to be 4 comma 0, 2 comma 1 and 0 comma 2, right? Just give me a second here. Yeah, so we will be going with a max of 1, 2, as well as from 2 to 0, then 2, 1 and 2, right? So this one will be max of 1 to 0 and this one will be max of 2 1 2, right? So max here is 2 and here also max is 2, either this 2 or this 2. So maximum will be 2 itself. Sum equals 2 plus 2 will be doing this one, type 1 plus type 2. So max number we got. So 4 is less than or equal to k, nothing but 4. 4 is less than or equal to 4. Yes, 4 is equivalent to 4. So this holds good, man. So this is valid. So length will be equal to 3. Maximum length, we are updating the maximum length from 2 to 3 here. See, right? So best, again best will be 2 comma 2 itself. So we have to move the right pointer to move to the next window. So this one will be r plus plus, r becomes 4. Previously r was 3, now the r becomes 4, right? So next, let's move on with the iteration 6 here. We will be going with the window 1 comma 4. So as we are going with the 1 comma 4, we will be considering the 4 droids this time, man. So 1 2 3 4 means 4 comma 0, 2 comma 1. Previously we had considered 4 comma 0, 2 comma 1, this one 0 comma 2. We will be considering along with the 0 comma 2, next one we will be considering 1 comma 3 as well, right? From this one to this one, this one to this one, and 0 comma 2 to 1 comma 3. So we are considering these four, right? 1 comma 2, 2 comma 1, 0 comma 2, 1 comma 3, right? So let's see the same thing here. Same thing, 1 comma 2, 2 comma 1, 0 comma 2 and 1 comma 3. Let's see the this one, maxima type 1 and type 2 we have to consider. 1 plus 2, this one among the maximum 1 2 0 and 1. Among 1 2 0 and 1, max is 2. Same thing, right? So among 2 1 2 and 3, this one 2 1 2 3, which is the maximum 3, right? So now we got 2 3, 2 plus 3, we have to sum up type 1 and type 2, right? The maximum value that we got, 2 plus 3 is 5, which is less than or equal to k. 4, no, it is not. 5 is not less than or equal to 5 or 4, right? So obviously 5 is greater than 4. So this is invalid window. This is invalid window. So we have to shrink left. Left was 1, if you remember, right? So we have to shrink left. Now we will be incrementing the left from 1 to 2, 1 to 2. So this is for the this one, window 2 comma 4, right? So now let's move on with the window 2 comma 4 for the iteration 7. So here we have droid 3 to 5, means we will be considering 3 4 and 5 droids, 3 4 and 5, 2 1 0 2 1 3. Next, let's move on with the maxima part. 2 0 and 1, among the max 2 0 and 1, 2 is the maximum, so we'll be considering 2. Among 1 2 and 3, which is the maximum here, 3 is the maximum, so we'll be considering 3 here, right? So now again we will sum this one. 2 plus 3 is 5. 5 is less than or equal to k, nothing but 4. No, 5 cannot be less than or equal to 4, so this is invalid as well. Again, what we will do, uh, the window is invalid, so we will shrink the left. L we had 2, we will increment the left from 2 to 3. We'll increment the left from 2 to 3, nothing but L plus plus to 3. So window is 3. Next we have to move to the window 3 comma 4, the final one, right? So 3 comma 4, the final one. So here we have this window itself. 4 is the last number I think we have, right? So yeah, window we have to move from 3 comma 4. This is fine. Just give me a second here. Yeah, 3 comma 4 elements droid we have 4, we are considering 4 to 5 basically. So the droids 4 and 5, the droids 4 and 5 according to with the input is 0 comma 2 is 1 comma 3, we know this one, so we have to go with the maximum of 0 comma 1 and maximum of 2 comma 3, nothing but 0 comma 1 maximum is 1 and 2 comma 3 maximum is 3. Quite obviously we'll sum up these things. 1 plus 3 equals 4. 4 is less than or equal to 4. Yes, 4 is equivalent to 4, right? So this window is valid. So this window is valid, right? So now length is 2, not greater than max length. So max length remains 3 equals 3 itself. So we are not updating the max length. So next we will be sorry, we will be incrementing here r. we'll be incrementing the right pointer r to 5. So here loop ends, basically loop ends, right? So r is less than n, so condition fails here, loop ends, basically will stop here, will stop here, right? So just give me a second here, 1 second. So before getting into the complexities part here, we have seen all the 8 iterations, right? So at the end, algorithm stored best is 2 comma 2, right? 2 comma 2 accordingly with the question. We have not went into the complexities part, just ignore this one, complexities for now. So at the end, the algorithm stored best equals 2 comma 2, right? So when we first saw the window 1 to 3 nothing but 0 best, the droids we considered was 2 comma 3 comma 4, right? So this was one best, which gives the longest contiguous destroyed sequence of length 3 using the shots 2 comma 2, nothing but this one using the shots 2 comma 2, right? So finally let's check, or let's apply the shots 2 comma 2 to each droid showing the destruction, right? So originally we have 5 droids, right? So one is so let's go with this one input man, just give me a second, why this is not working, 1 second man. We have this one, let's consider this one. I have already written too much in the first this thing. So original is here 4 comma 0, the second droid is 1 comma 2, 2 comma 1, 0 comma 1, and the final one is 1 comma 3. So this one we have to apply the shots 2 comma 2, right? So we have to apply the shots 2 comma 2 to reach the droid, nothing but we are showing the destruction here. So after minus 2 comma 2 we have to consider, right? So this one will be uh, 4 comma 0, 2 comma 0. We have to go with minus 2 comma minus 2, right? So this will be 2 comma 0, 1 comma 2, so this will give us 0 comma 0, and 2 comma 1, this will also give us 0 comma 0, and 0 comma 2, this will also give 0 comma 0. We are going with after minus 2 comma minus 2, right? So for 1 comma 3, for this one also this will be 1 comma 3, right? So we are going with a minus 2, 3 comma this one minus 2 will be minus 1, right? So this one will be minus 2, it won't go below 0. So yeah, below 0. So 1 minus 2 minus 1 will get, we will give 0 here itself, 2 minus 2 0, 2 minus 2 0, 1 minus 2, this will be 0. We are applying minus 2 comma minus 2. As we are going with a final check, we have to apply the shots 2 comma 2 to each droid. That is nothing but we are showing the destruction here. So this one will be 2 minus 2 0, 1 minus 2 will be minus 1. If we get into the negative value, then we will be displaying 0, right? So that is the reason we are going with 0 instead of minus 1. 0 and 1 we have 0 0 minus 1, this one minus 2, again this will be 0, 1 minus 2, this will be minus 1, this will be 0, 3 minus 2, this will give us 1, right? So for the first one we have 4 comma 0, this will be 2 comma 2 because 4 minus 2 is 2, right? 0 minus 2 is minus 2, and the negative value if we get, we will be displaying 0. So this is after 2 comma 2, this one minus 2 comma 2. So this is destroyed, no, this is not destroyed, right? So this is not destroyed, right? So we have 2 comma 0, we have the value, right? So this is not completely destroyed. 1 comma 2 we have 0 comma 0, yes, this is destroyed man. 0 comma 0 again, this is destroyed. 0 comma 0 again, this is destroyed. Whenever it is destroyed, we have to return the boolean value, yes. This one, not boolean value, yeah, you can consider the boolean value, but in this case we have to go with a yes instead of true, that's it. So here we have 0 comma n, this is destroyed, no, this is not destroyed. 2 comma 0 and this one 0 comma 1, they are not destroyed, basically destroyed. 4 comma 0 and 1 comma 3 are not destroyed. These three droids are destroyed, right? Accordingly with the this one approach, the 8 iteration we saw, right? So 2 comma 2 is the thing that we need to apply on. Basically we have to apply shots 2 comma 2 to each droid here. So the output that we got here is no, yes, 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 no, no triple s, no, right? So the output that we got here is no triple s, no, which is equivalent to the output this one they have given here, right? So the output that we got here is 2 comma 2, and the output that we got, main output is so this one, no triple s, no, basically, right? So the output that we got here for the within the approach, or the output that we got is 2 comma 2, which is equivalent to the output that they have given for the this one example 1, or the input 1 within the question, right? So the approach works absolutely correct in this case. So now as we are completely familiar with the approach, let's move on with the complexities part, man, right? Let's move on with the complexities part. So what will be the time complexity here? The time complexity would be big of m into n into logarithmic n, m into n into logarithmic n, because building m sparse tables, as I have said here, we will be going with a sparse table along with a sliding window, right? So let me write it over here. Just give me a second. What happened to this one? One second. One second. Yeah, we will be going with a sparse table along with a sliding window, right? So here, the time complexity would be big of m into n into logarithmic n, because building m sparse tables takes big of m into n into logarithmic n, and the sliding window does m into n queries, right? Queries big of 1 each. So overall time complexity is dominated by pre-processing, nothing but by the sparse table. So what is the sparse table time complexity that we get here? Big of m into logarithmic n. So this is dominated by the sparse table, so overall time complexity would lead to big of m into n into logarithmic n. So what would be the space complexity here? Space complexity would be big of m into n into log n as well, because we are making use of the sparse table, and sparse table stores m tables of size n into floor of log 2 into n whole plus 1, right? So basically plus a few big of m extras as well we will be making use of. So overall space complexity would lead to big of m into logarithmic n as well, right? So this is the time complexity and the space complexity for the code that we'll be writing in the future. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n into logarithmic n respectively for both, right? So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code here. I'll just come to the compiler. So we will be going with a fast input and output. So I'll be importing uh, input output package. Also, I'll be going with a different utilities as well. I'll just go with java.util.start. So this is fine. Next, let's go with the main class name. Uh, main class. So I'll just go with the main here class name. You can just give any relevant name. That is relevant to the question basically. So let me make the M capital here. This is fine, man. So within the main class, what should we do? Let me go with the global variables, number of droids, types, and the allowed shots, right? So nothing but NMK. So according to with the input static here, int n comma m comma k. So this is fine. So next, let's go with the main method here. This is fine. So this one will be throws input output exception. So this is also fine. Now let's do one thing. Let's go with the fast input first. So I'll just go with buffered reader br equals new buffered reader new. This will be input output. Mm, and we are just going with a this one, right? Input stream reader. Sorry. So this has to be input stream reader system dot and inbuilt basically. So this is fine. So this is coming from the input output package. So I'll just go with string tokenizer here. So let me consider the variable name st new string tokenizer. Yeah, this one buffer data we have already made use of br dot. Let me give here read line. So this is fine. So the next part would be here. We have to parse n, m, and k, nothing but the number of droids, number of types, and this one max available shots. So this will be n equals integer dot parse end of this one string tokenizer dot next token. So this is fine, man. Next we have to go with the m. So let's do the same thing for m and k as well. This is fine. m, and this is also fine. This will be m, and this will be k. This is fine. This remains same, right? So we are just passing n, m, and k. So this is fine. Let's move on with the further steps here. We have to transpose the storage, nothing but array of type index. We have to assign this one to value. So I'll just write it on this way. Array. I'll just go with new int uh, m and n, right? So this will be m and n. This is fine. Let's iterate the rows, nothing but we have to iterate through the droids, right? So I'll just go with a for loop here. This will be int I equals 0, I less than n. So this will be I plus plus. So within the for loop, let me read the next droid line. Along after that, we have to iterate the types in that droid as well, right? So now currently we are just iterating the rows, nothing but the droids. Why? Because we have to read the next droid line. So I'll just go with the string tokenizer st here, new. Let me create the instance of it. This one string tokenizer. So this one will be buffered reader dot read line. This is fine. Next we have to iterate through the one more for loop here. So we have to iterate types in that droid. So I'll just go with one more variable here, j equals 0, j less than m, and j plus plus. So this is fine. So within this for loop, so we have to store the transposed ones, right? So now this will be array of ji. Mm, so this one will be integer dot percent of string tokenizer dot next token. So this is fine, right? Yep. We are storing the transposed ones. So let me come out of this one entirely. So now so we are going with a sparse table. We know this one, right? So before going with the instance of the sparse, I want to go with a customs this one sparse class, custom sparse class, right? So let's go with the sparse table class for the range maximum queries on an int array. You can also go with the this one segment tree as well. So I'll be going with the sparse because the code will be somewhat small compared to this one segment tree. So I'll just go with class. So where I have given capital C for the class, this is showing, yeah, this is fine, man. Class, this one I'll just give here sparse class sparse. So within the sparse class, so first let's go with a maximum of the subarray starting at the I, nothing but string tokenizer of ij. So we are assigning that one to the maximum of subarray starting at I with a length 2 to the power of j, right? So for initially let's initialize it, right? So we have to go with int st. This is fine. And also I'll just go with a int, so this one log, as we are dealing with a sparse table, nothing but log of x equals floor of log 2 of x, right? So if you don't know the sparse table, I have written the this one blog, right? So while I was solving the problems on the node.js, I had written the this one blog basically. This one logic remains same, programming language different, nothing but I have made use of the javascript or the node. So the logic remains same, you can just go through that one. So if you just google it, you'll get it, right? So let's go with the constructor. Once let's build the sparse table for the given array. So I'll just go with sparse here, int array. So this is fine. So within the initialization part, let we will be making use of the length of the array. So most of the time, so I'll just assign this one to the n. This is nothing but the length of the array. We have to prepare the log table, so I'll just assign the log to new int of this one within the array. I'll just give n plus 1. And also we need to fill all the log values as we are dealing with the sparse table. So I'll just go with int I equals to I less than or equal to n, I plus plus. So I'll just go with iterated value of the log here itself in the same line. So this will be log of I by 2 plus 1. So let's move on with the further things here. First, let's go with the maximum power. Means we have the k. Let me assign the k to maximum power means log of n basically, right? So now let's allocate the sparse table. Nothing but we are having n rows and k plus 1 columns, right? So I'll just go with the string tokenizer st here, new int of this one will be n and also k plus 1. So this is also fine, man. Let's go with a for loop here. For loop. So this will be for int I equals 0, I less than n. So this one will be I plus plus. So this one will be st equals st of I 0. This one will be array of I. This is fine. Again, one more for loop. So this one will be int j equals 1 and j less than or equal to k. This one will be j plus plus. So this is fine as well. Let's go with one more for loop, nothing but for each starting index that fits, right? So here we need to combine two halves of length, right? So nothing but we have to go with 2 to the power of j minus 1. This is completely pure sparse table actually to get the length 2 to the power of j. So for that one, we'll be writing the this one for loop, one more iteration. So don't get confused here. So this one will be for int I equals 0, I plus. So 1 left shift operator here. This has to be j, sorry, not k. Got confused, man. It has to be less than or equal to n I plus plus. This is fine, man. So we are going with or we are going for the each starting index that fits basically. So within this for loop, I have to combine two halves of length 2 to the power of j minus 1 to get the length 2 to the power of j. So this one will be string tokenizer of ij, that is equivalent to math.max here. This one st string tokenizer of I j. This is fine. So this one has to be j minus 1 comma string tokenizer. So this one will be I plus 1 less than or equal to j minus 1. This is also fine. This will be j minus 1. This is fine, man. We are done with this part. You don't have to worry about that one very much actually. It's completely related to the sparse table. So this one we are going with a query, right? So because we have to go with a query as we have to deal with a query maximum on interval L comma R, that is inclusive, right? So and this is zero based indexing, right? So we had discussed this one on the approach as well. I had stressed this one, right? Let me go with int query here. This one is int L comma int R. So this is fine. So if L is less than R, so this has to be greater, right? We went with greater in the approach. Yeah, L is greater than R. Then let me go with return 0. So if the we are just going with the empty interval guard here, right? So we'll not be usually making use of it, but if L is greater than 0, then we have to return 0. That is also one of the edge cases we have to write in the form of code anyway, or else we'll be getting the error. So next we have to go with the largest power of 2 fitting into the interval length, nothing but. So here in this case I can articulate the same thing in the form of code in this way: log of within the array, this will be r minus l plus 1. So this is fine. So the final thing is we have to go with the answer, that is max of two overlapping intervals of length 2 to the power of j, that is covering L comma R. We have seen the step by step iteration part, right? So from 1 to 8, finally we got 2 comma 2 answer, and we saw that the destruction part as well by considering minus 2 comma 2 on all the droids, right? So we got no triple S no, if you remember, right? If you remember, so answer is nothing but the max of two overlapping intervals, the final one, this one, the 8 iterations what we went with, I showed, right? So answer is nothing but the max of two overlapping intervals of length 2 to the power of j covering L comma R, right? So I can just return here math dot max of string tokenizer of L R. So this one will be LJ, sorry, not R, right? So for R, we have to go with this one string tokenizer again. So this one will be R minus 1 left shift operator J. This one plus 1 plus 1. So this one will be finally J, man. Finally, J. So we are done with the sparse class. We are done with a custom sparse class, right? So let's implement the same thing in the form of code here. So where we have left, I have forgotten, man. Completely forgotten here. This is fine. So I have given here array of ji equals integer of one is next token, right? So we have stored the transport basically. Now we have to go with the array of sparse tables, one per type, nothing but the column. So I'll just go with the we have written the sparse class already. Let's make use of it actually. A sparse. So this one will be sparse. So sparse columns. This one will be new sparse of m. So this is fine. The next step would be here. Let's go with the for loop. Let's build the sparse table, right? So now here let's build the sparse table. We will be making use of the sparse table at any cost. So int I equals 0, I less than m. So this one will be I plus plus. So I'll just go with the sparse columns here. This one of I, this one if equal to new sparse of iterated value of the array. ARR we have considered, right? So this is fine. So next let's as per the this one approach, we went with the keywords. This one for the variable name keywords, we went with the maxlen and this one LR, right? So for we have to track the best window length and its left index, nothing but best L. So if you remember the approach, so I'll just go with maxlen variable name, initialize this one to 0, also best L to 0 as well. Next let me initialize L to 0 comma right window to 0 as well, left and right, as we are going with a sliding window. So this is nothing but the sliding window pointers L comma R. This we are considering this is 0 based indices, right? So now this is 0 based indices, just keep this in mind, right? So we have to go with the one best index finally. So let's go with the best vector of shots per type for the best window, right? So let's go with the array list, right? So we have to store somewhere. Let's go with the array list. So this will be list of integer. This one will be, sometimes I go numb man. So while typing, so let us will be dancing. All I see is this one green color, the colors that are present in this one compiler part. So this will be best. Uh, just give me a second. Let me type slowly. So this will be array list. This is fine. Yeah. Let's move on with the next part here. So pure sliding window, right? So we'll be going with the pure sliding window. So we have to expand R until end and maintain the window L comma R. So first sliding window left, sorry, right, we are considering right less than n, then only we can move forward. Means we have to go with the sum of maxima of each type in the current window. So let me initialize sum to 0. This is fine. Let me go with the for loop here. This one will be int I equals 0, I less than m. So let me increment the I. So within the for loop, let's add the maxim L comma R for type I. So this one will be sum equals sum plus. Let me go with the sparse columns. So this is also fine of I dot this one. Let's go with a query. Let's go with a query of L comma R. So this is fine. Let me come out of this one entirely. Let's go with a simple if condition here. If sum less than or equal to k, then if we can destroy this whole window with less than or equal to k shots, that's what we need to check, right? So that is the reason I have written the if condition here. So if we can destroy this whole window with less than or equal to k shots, let's go with the within this if condition, let's go with the current window length first. So that's what we saw in the iterations as well, right? So whether we can destroy or not. So here length equals r minus 1, sorry, this has to be right minus left, right, plus 1, basically, as we need to deal with a one based indexing here. So this is fine, man. Let me write one more if condition here. If length greater than max length, then what we need to do means, if strictly better, then we have to update the best result, right? So let me assign max length to the length, and also let me assign best left to the left. One more thing, we have to reset the best vector, nothing but here on this case best equals new array list. So just give me a second here. New, we have already made use of the array list, so just the syntax part, right? So this is fine. So let me go with the iteration here, because we have to store the maxima per type, right? For the particular window, right? So for the particular window we have to store the maxima per type. So we saw that one during the approach, right? So let me go with the for loop here. We are done with this part, right? So just give me a second here. This is fine. Let me go with the for loop here. This will be int I equals 0, I less than m I plus plus. This is also fine within the for loop. So I'll just go with best dot add. So let me go with the sparse columns. This is also fine of I dot let me go with a query here. So this method we are making use of, we have already written the query within the class sparse, right? Sparse class. So let's go with this method query here. Query of, let me pass the parameters l comma r. So we are just storing the maxima per type for this particular window. So we are done with this part. Let me come out of this one entirely. So now if you remember in the approach, so if it is a valid window, then we have to increment the r. Means we need to try to expand the window to the right, right? So I'll just go with r plus plus here. Else what we have to do here, window needs to shrink from left to reduce the sum, nothing but we have to this one increment the L. Finally, we have to ensure or make sure that the window is valid. If L passed R, we have to move R to L, right? So this one, we have seen the same thing within the iterations, right? So I'll just go with L greater than R. So let me assign the R to L. So this is fine, I guess. So now let me come out of this one entirely. We are almost done with the code. What we need to do here, if no window is found, right? So if no window is found, we need to print the 0, right? So we need to print the zeros. Else we have to print the chosen shots per type. Else we have to print the chosen shots per type. In our case, we finally got the answer 2 comma 2. Nothing but the chosen shots for 2 comma 2. So when we applied that chosen shots on the droids, we got no triple s, no. That also I showed you the answer, final check, that also I showed you, right? So that's what we'll be doing here. If no window is found, then we need to print the zeros, else we have to print the chosen shots per type, right? So for that one, let's articulate same thing in the form of code. So this one will be best dot is empty, best dot is empty. So this is fine. So within the if condition, let me go with for loop. This one will be int I equals 0, I less than m. So this one will be I plus plus. This is also fine, man. So let me go with here. mm, so this one will be system out. Print ln is not required, I think. So print is enough. So because we have to print the 0 in the same line, right? So we just have to print the 0. Let me give 0 here along with the space. We are just printing the zeros. Else what we need to do, else we have to print the chosen shots per type, nothing but here again one more for loop in individual value from the best, nothing but we are printing the chosen shots per type, right? So this one is of best, individual value from the best. Let me go with uh, again this print some message we have to print, right? So this one will be, let me go with value. We have to concatenate this one. We need to we need to leave the space right here. See here in the output, 2 space 2, we need to leave the space. So this one, right? So we are done with the coding part. So somewhere I have missed something. I don't know what I have missed, man. Seriously. See here, this is fine. Yeah, this one, let me cut this one and let me paste it over here, right? So I should have written the sparse table uh, from here actually. One bracket I have missed, basically misplaced the brackets. So here, this is fine. I have moved this bracket from here. So now, before checking the code, with the different inputs, I want to copy paste the signature starter template. Just give me a second here. So just give me a second here. Yeah, let me paste this one. Let's concentrate on the logical part, man. So let me come here to the question. Let me copy the input here. We come again to the compiler. Let me paste it over here. Run the code. So we are getting the error here. Expected semicolon 26. Let's see. 26. Yeah, I have not given semicolon here. Let me run this one again. So we have many errors, man, 8 errors. Let's clear one by one quickly. So we have here int has been misspelled here. I have misspelled int line number 44. Let's quickly remove G here. This is fine. Let me run this one. Yep, that error is gone. Now we have incompatible types. Int cannot be converted to int. This one have this one. Where is it? Line number 89 within the mm, sparse table, right? So what is wrong here? Just give me a second. So this is showing std equals new int of nk. Incompatible types. Int cannot be converted to this. Somewhere we have done this one. Just give me a second here. Mm, so this one I have given correctly, right? Int. Oh yeah. So this one I have to give one more array here. So that is the reason we were getting the error. So let me run this one. This error has to be gone. Yeah, now we are left with two errors. One is array required but int found, line number 94. So this one, what is wrong here? mm, Math.max of int comma int is not applicable, no suitable method found for max. So first let's go with the line number 94. This one, the same thing, right? Math.max. So we have written three for loops here. This is pure sparse table, man. So this is I equals 0. This is fine. I plus 1 left shift j. This is fine. Less than or equal to n. I plus plus. This is also fine. String tokenizer ij. We are just combining the two halves of length. This one 2 to the power of j minus 1 to get the length 2 to the power of j. So that's what we are doing here in this step, line number 93, 94. So this one string tokenizer of ij, math.max of st, yeah, I, this one j minus 1, this is also fine, comma string tokenizer, this is fine, I plus 1 left shift operator, j minus 1, this is also fine. J minus 1, I'm still not getting where I have went wrong, man. So j minus, oh yeah, I have given one this thing. One more. Why I have given here? Have I done something wrong here? No, I have closed. So this one I put. Where should I close this one? This is fine. Yeah, this one I have to close here. So yep. So I had closed here instead. This is fine. Now if I run, I hope this works now. Yeah, we are getting the output 2. 2, right? So we are getting the desired output. Let's check with the second input. So now if I copy this one, I have to get the output 1 3, right? So let's check the same here. Let me run this one. So we are getting the output 1 3. So that was the problem basically. Misplacing of the brackets again. So this one here as well, I had misplaced the brackets. Yeah, this is fine, man. Now we are getting the desired output, right? So I'll just copy this one entirely. Let me come to the question. Let's get into the submission part. So let me click on the submit button. Let me paste the entire code. Let me hit the submit. So I hope this works for all the test cases. Let's see. So this will be slow. Yeah, let's wait for some time. Yeah, running on test 2, 3. This is very slow today. I don't know why. Yeah, we have went with a pure sparse table and the sliding window. This is complete sliding window with a sparse table approach, right? So we have already solved a number of problems using the sliding window. And for the sparse table, if you really want to know this thing, how sparse table works, you can just go through the blog. So I have written that one when I was solving the Node.js, when I used to solve the problems using Node or the JavaScript. Now, if you still want to know, so I'll be explaining the sparse table within the in Python as well. So next we'll be going with the data structure concept. So I'll be explaining about the this one only the certain data structures, right? So I'll be explaining about the segment tree, fenwick tree, sparse tables, trees. First we'll be going with the trees, list, tuples, everything. So in that part also you can just you'll get to know about the sparse tables. So no worries. So here you can clearly see the verdict we are getting accepted. Means whatever the code that we have written works absolutely correct for all the test cases, right? So now I hope the solution part is completely clear, man. I hope the solution part is completely clear along with the this one approach and the complexities part. Right. For now, this is it. Thanks for watching, guys.